Hello everyone, welcome back. In the previous videos, we have learned how multiple register transfer instructions work in ARM state. Now, let's see what changes when we switch to Thumb-1. The first difference is the available instructions. In ARM state, we have four addressing modes for multiple register transfer as shown below. That is, load multiple increment after or store multiple increment after, load multiple decrement after or store multiple decrement after, load multiple increment before or store multiple increment before, and load multiple decrement before or store multiple decrement before. But in Thumb-1, only load multiple increment after and store multiple increment after are supported. The other addressing modes are not available. The second difference is the register limitation. In ARM state, both the base register and the register list can use almost any general purpose register. For example, this store multiple increment after instruction is perfectly valid. In Thumb-1, both the base register and the register list are limited to R0 through R7. Registers like R8, R9, link register, program counter cannot be used with the general load multiple increment after and store multiple increment after instructions. Another important point is that write back is mandatory in Thumb-1. So after the transfer, the base register is automatically updated. Now you might wonder, if Thumb-1 supports only store multiple increment after, then how does this instruction work? That is, push followed by register R4 to R7 and link register. In ARM state, pushing registers onto the stack is typically done using store multiple decrement before, but Thumb-1 does not support the general store multiple decrement before instruction. The answer is that push is a separate Thumb-1 instruction with its own 16-bit encoding. Internally, it performs the same stack operation, that is, decrementing the stack pointer and storing the registers onto the stack. Similarly, pop restores the registers from the stack and loads the final value into the program counter. Notice the special register combinations supported by Thumb-1. Push can include link register, pop can include program counter, but push cannot include program counter and pop cannot include link register. These are Thumb-1 encoding restrictions. Now let's verify everything that we learned in the theory using the Keil software. I'm assuming you already know how to create a basic Thumb-1 project and how to switch from ARM state to Thumb state. I have already explained that in a previous video, so we will start directly from the Thumb code. After switching to Thumb state, execution reaches the label Thumb code. Before using push and pop, we initialize the stack pointer to a valid RAM address. Since these instructions use the stack, that is, SP must point to valid memory. The first two instructions load the addresses of our source and destination arrays. Here, R0 will act as the source pointer while R5 will act as the destination pointer. Notice that both are low registers. This matches what we discussed earlier. Thumb-1 allows only R0 to R7 as the base register for load multiple increment after and store multiple increment after. Next, we execute load multiple increment after instruction. This loads 4 consecutive words from the memory pointed to by R0 into R1 through R4. As execution proceeds, you will see the registers receiving the value stored in the source array. Also notice that R0 is automatically updated after the transfer because write back is mandatory in Thumb-1. Now we store those values into the destination array using store multiple increment after instruction. When you execute this instruction, the contents of R1 to R4 are written into the memory pointed to by R5. If we open the memory window, we will see that destination array now contains exactly the same values as the source array. Again, notice that alpha is automatically updated after the transfer. Now let's move on to the stack operations. The instruction to be considered here is push, and the register list we have is R1 to R4. Notice that we are pushing only the general purpose registers in this example. Before executing this instruction, note the current value of the stack pointer. After executing push, the stack pointer decreases and the values of R1 through R4 are stored on the stack. Next, we intentionally clear the registers using these instructions. This simply helps us verify that the original values are actually restored from the stack. Now we execute pop instruction. The original values are loaded back into R1 through R4 and you will see that all four registers are restored correctly. Remember, including link register in push and program counter in pop is optional. We are not using them in this demonstration because our goal is simply to verify the stack operation. However, as we discussed in the theory, Thumb-1 does allow these special register combinations. That is, push can include link register, pop can include program counter, but push cannot include program counter and pop cannot include link register. That's all about this video. I'll see you in the next one.